Hello guys, in this video we are going to discuss the solution of the problem add two numbers represented by linked list. So let us look at a problem statement. The problem statement says that given two decimal numbers num1 and num2 represented by linked list of size n and m respectively, the task is to return a linked list that represents the sum of these two numbers. For example, the number 190 will be represented by the linked list 1, 9 and 0. Similarly, 25 will be represented by 2 and 5, and sum of these two numbers is 215, which will be represented by 2, 1 and 5. You are required to return the head of the linked list 2, 1, 5. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in this problem, two linked list is given to us. So let us say linked list 1 is given to us, and let's say that linked list is 123. So this is how the number 123 is represented in the linked list format. Similarly, let us say another linked list is given to us, and let's say that linked list is 45. And this is how 45 is represented in this linked list format. And then we need to add these two elements. So the addition of these two elements will be 168. And the sum is something which we need to do, and we need to return the head of that linked list. So after summation, the resultant linked list will look something like this, and the head of the linked list, which is this, is what we need to return. Now here there are some caveats to this problem. The first caveat which we have is that the linked list can contain zeros at the beginning too. So for instance, let us say there is a number 35, then rather than representing 35 like this, the linked list which is given to us could be of this nature also. And as you can see, this is also 35. So this is the caveat 1 I was talking about. The second caveat which we have, and you can see from the linked list representation, is the head points to the MSB. Whereas if we want to perform sum, we need to start from LSB. So these are the two caveats which we have, and when we will be solving this problem, these two things is something which we will try to address. So now let us discuss the algorithm for this, and let us see how we will be addressing these two caveats in our algorithm. So let us discuss the algorithm for it. So let us say we would like to add two linked list, and the two linked list which is given to us is represented by num1 and num2. So the first thing which we are going to do is we are going to remove zeros from MSB from both of the linked list. So let us remove that. So let us say we have a function which is remove MSB 0, which takes a linked list as an input, and it removes zeros from the beginning, and it returns the head of the linked list to us. Similarly, we are going to remove zeros from the second linked list too. After removal of zeros from first and second linked list, it might be possible that both the linked list becomes empty. So I'm talking about the cases where the linked list has, let us say, zeros. So let us say the num1 linked list is this, and num2 linked list is this. And since remove MSB 0 is something which will remove all the zeros from num1 and num2 linked list, thereby the linked list will become empty. So in the case where num1 and num2 both becomes empty, in such cases we realize that the sum would be 0. So that is what we are going to return. So we are going to return a linked list which contains just one node, and that node information is 0. So this is how we are going to return it. Otherwise, it might be possible that linked list 1 becomes empty and linked list 2 remains as it is. So if linked list 1 is empty, in such case we can return linked list 2. Similarly, for the cases where linked list 2 becomes empty, we can return linked list 1. Now if these conditions are not satisfied, then what we need to do is we need to perform addition of these two linked lists. So before we could go ahead and perform addition, what we will do is we will convert the linked list into array format, or we will represent the linked list into array format. So let us say this is the first linked list which we have, and we want to convert this linked list to array. So let us say we have a function to do that, linked list to array, and we are passing our first linked list to this, and this function converts the linked list to array and it returns the array. So A is an array which contains the array representation of linked list. Similarly, B is another array which contains the array representation of second linked list. So what do I mean by this is, let us say num1 linked list contains 1, 2, 3. Then the A array will contain 1, 2 and 3. Please note the ordering remains as it is, which is the 0th position of the array contains MSB and the last position of the array will contains LSB. The reason why we are converting it into array is because we want to iterate from LSB. The time it takes to iterate on array is order 1, whereas if I have to fetch an element in a linked list, I need to invest order of n time. So that is why in order to reduce the time complexity, we are representing the linked list into array format, and then we will use this array in order to perform the sum operation. And please note the sum will start from LSB. So once we have the linked list represented in array format, we will perform the sum operation. So let us perform the sum operation. So we would like to add A and B, and this function add, it will perform the sum operation and it will represent the resultant sum into a linked list format, and it will return the head of that linked list, and then towards the end we are going to return answer. So that's the algorithm, folks. Now, as we have seen, we are using various functions in order to achieve to our answer. So now let us go ahead and discuss various functions which we are using. The various functions which we are using here is, the first function which we are using is this, remove MSB 0. Then the second function which we are using here is LL to array, linked list to array. And the third and final function is add. So now let us take each of these functions one at a time and discuss it at length in order to understand its implementation. So let us take the first function, which is remove MSB 0. So in this function, a head of a linked list is given to us and our task is to remove the zeros from MSB. So let us do that. So in order to remove zeros from MSB, what we are going to do is we are going to iterate on the linked list while head, and we are going to iterate till the MSB is 0. So head.data equals to 0. We are simply going to increase head to the next element. So head equals to head.next, and then towards the end we can return head. And in this way we will be able to get rid of all zeros from MSB. So that's about the first function, folks. Now let us discuss the second function, which is linked list to array. So over here a linked list is given to us and our objective is to convert this linked list into array format. So before converting linked list into array format, let us say this is our answer list. The first thing which we are going to check whether this is an empty linked list. If this is an empty linked list, then in such case we can return answer. Otherwise, we are going to iterate on the linked list. So let us iterate on the linked list, and we are going to push all the elements of the linked list onto the array. So let us do that, and after push we will increase our head pointer, and then towards the end we will return answer. So in this way we will be able to convert linked list into array format. Now let us discuss the final function which we have, which is add function. So in the add function, there are two arrays which is given to us, which is A and B, and we would like to perform the sum operation of this array. So the first thing which we are going to do is we are going to set I to the LSB of array A. So let us set that length of A minus 1. So remember, the least significant bit is at the end of the array. Similarly, J we are going to set it to the LSB of Bth array, so which we can do it in this format, and then we will have our answer, and this is equals to none initially. Now we are going to iterate on array A and B while I is greater than and equals to 0 and J is greater than or equals to 0. So we will iterate on array A and B till this condition is satisfied. Then we would like to perform the sum. So before performing sum operation, let us say there is a carry variable with us and initially its value is 0. So now what we are going to do is we are going to perform the sum operation. So sum equals to AI plus BJ plus carry. This sum could be greater than or equals to 10, in which case we will find the data part of it, and the data is s mod 10. So we'll get the data, and since it is greater than or equals to 10, so the carry will be there and carry will be equals to 1. Otherwise, if sum is less than or equals to 10, then data is equals to s and carry in this case is equals to 0. Now once we have performed this sum operation, we would like to insert this sum to the linked list, to the answer linked list. So before inserting into answer linked list, let us have a node with us. So node is equals to node of data. So we get a node which contains data, and now this node needs to be inserted to answer. So let us do that. So answer equals to insert at head, and here the insertion will be at head. And what is it that we want to insert? Well, we want to insert node into answer. So answer is the head of the linked list, resultant linked list, and node is the node to be inserted in answer. And why we would like to insert at the head of the linked list? Well, in order to understand that, let us say there is two arrays with us which contains 1, 2 and 3, and there is a second array which contains 4, 5 and 6, and we would like to perform the addition. So this is how our answer should look like. And in order to achieve this, so we will perform 6 plus 3, which is 9. So initially our answer will be 9, and then we will perform 5 plus 2, which is equals to 7. So once we insert at the beginning of the linked list, then this linked list will become 7 and 9, and then the 4 plus 1 equals to 5. I'm sorry, this will be 5. 4 plus 1 equals to 5, and once we insert at the beginning, this becomes 5, 7 and 9. And that is the reason we are inserting at the head of the linked list rather than at the tail of the linked list. Now once we have inserted this, we would like to increase or rather decrease our ith and jth counter. So let us do that, and in this way we'll be able to perform the addition operation. Now it might be possible that after performing the addition operation, there exists some elements or some elements from ith array is still present. So in such case, we will just go ahead and perform our add operation again. So in this case, s will be equals to ai plus carry, and then the same thing, if s is greater than or equals to 10, then data equals to s mod 10, and carry is equals to 1 in this case. Otherwise, data is equals to s and carry equals to 0, and then we'll get a node. So node is equals to node of data, and we will insert this node at the beginning of the linked list. So let us do that. So answer is equals to insert at head, and node is what we want to insert, and then let us decrease our ith pointer. Similarly, it might be possible that there exist certain elements on bth array which is yet to be addressed. So in that case, j is greater than or equals to 0, and we will do the same thing, which is, let us perform the sum operation, which is equals to b of j plus carry, and now let's get our data and carry from it. So if s is greater than or equals to 10, then in that case data is equals to s modulo 10 and carry is equals to 1. Otherwise, data is equals to s and carry equals to 0. And once we have done that, we would like to add this to the beginning of the linked list. So let us do that. Insert at head, answer and node, and then we will decrease our jth pointer. So let us take this example, for instance 99, and we would like to add 1 to it. So now as we know, this will be 100. So what will happen is that we will perform this operation, and the result is what something we will be able to update it like this, but the carry will be 1. So it might be possible that after performing all the addition operation, there exists some carry. So that is what we are doing. If there exists carry, then this carry needs to be inserted to the linked list also. So that is why we are checking if carry, then insert it to the head of the linked list. And before inserting it, let's have our node. So node is equals to node of carry, and then this node will be inserted, and then towards the end we will return answer. So in this way we will be able to add two linked list and return the resultant linked list. So that's about the discussion, folks. Now let us see how we have implemented this in Python. So folks, the code is pretty much the same as what we have discussed. I'm not going to run over the code one more time. There is a bit of optimization I have done in the code. As usual, I'm going to paste this code in the comment section. So if you want to take a look at the code, you can also go ahead and glance over the comment in order to understand the code. For now, let us just submit our solution. Our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.